all been invited to this Canvas page. I think everybody's accepted it, so you have access to this Canvas page. And I've given you a physical copy of the notes that we're going to go through that are kind of like half on, or like one slide on half of the page. And that corresponds, if you kind of look up on the, either your screen or the board here, that corresponds to this link right here. So if you wanted to print out another copy of these like the by hand notes, you can do that right here. If you would rather take notes on your iPad using Notability, then there's another link that you can use. I would use one of these two. It's all three of these up here. Open up this same set of notes, but full page slides, so you can like write in Notability. So it's completely up to you. If you do want to use Notability, go ahead and load that in right now. And if you're just going to use the paper one, you're good there. So as far as the main page here should have everything that I have kind of to offer you regarding the prepping for this new digital SAT, right? How many of you guys, has anyone loaded the Blue Book app yet? Okay, so remember your SAT, when you start to take them from now on, you bring a device with you, and with this Blue Book app loaded on it, and that's what you're going to take your SAT on. Okay, now with an iPad, which is what I'm going to assume everybody's using, you can have an external keyboard. At least I believe I read that is allowed, so you can have your keyboard with you as well. Okay, definitely load it and take a look at it so that you can kind of get familiar with it and used to it and how it works. Okay, good morning. Go ahead and grab a packet there and check off your name, please. As far as coming back to this page here, the left side right here of this main page has all of the links to the practice tests and practice content that I've created. And all of those questions are based on the stuff that the digital SAT has put out there. Okay, but they are all questions that will change every time you take them. So any of these tests on the left side, okay, are going to change every time. Okay? So if you want to practice Module 1, the first, or the Module 2, the hard version of it, Module 2, the easy version. So again, the way that the SAT is set up now, or starting this weekend, is that you'll take a 22-question math section. It'll be like section 3 or something. And then based on how well you do, you will either get an easier version of a second set of 22 questions, or you'll get a harder version. So it's adaptive in that sense. It's not adaptive in that if you answer a question right, they get harder. It's just adaptive in that, or from, again, what it appears and what they put out there, is that you either go to the easier questions or the harder questions. So if you want to see kind of the difference between those, you can look at these links right here. So I have 4 versions of the hard types of questions, and then 2 versions of what the easy questions would be. If you want to take just the full length digital test with 22 questions, again, it's 22 questions. They changed the format of the SAT in hopes that that 35-minute time limit to do 22 questions is not a time constraint for anyone. Okay? And so if you have extended time, you still have extended time, but the whole point of this change was to make it so that you don't have to feel totally rushed to complete the test like has been in the past. So again, just kind of keep that in mind. Winter, go ahead and you can grab a packet right there. Okay, and then finally, there's 104 questions here in this packet. The way I've broken down these questions is the same as the approximate percentages. So if you look right here where it says there's about 33% of the questions that you'll see on the SAT are Algebra 1 topics. Okay, 35 of the 104 questions in this packet right here are that. So that's about 34%. So all of the percentages of what we're going to do is pretty similar to the percentages of a single test. And so if you want to kind of take some practice tests over just the questions that I pulled out, and again, the questions that I pulled out are the ones that I've recognized as patterns that show up the most in these practice tests that they've put forward. So again, it's not a guarantee that that's what you're going to see, okay? But again, these are the most common types of questions that I've seen going through the material that they've shared with educators. Okay, so that's this left side. So the left side here, any of these links on the left side open up a My Open Math quiz or test that you can take as many times as you want. It'll give you instant feedback. It'll display solutions to them anywhere. There's a video capture of me solving a similar question. It's posted there too. So that's all stuff that you can do on your own. And inside every question, I'll go through an example here, but inside every question, there is an opportunity for you to ask me a question or send me a message about that question. So if you are working through this problem here, which is the hardest problem that you can, actually, that came up first. But if you had some problems or issues with that, you could either show the detailed solutions, okay, or a worked example to see these are the step-by-steps of how you would look to solve that. If there's still questions, just hit message me, message instructor. It'll send me a message. You can do this at any time. So even if you're like studying at midnight, hey, it's not going to wake me up, but the next time I check my email, I'll see that you had a question for me and I will get back to you. You can always, if you are expecting a message back from me up here when you log in or take a test, it'll connect you automatically. And if you see this little envelope button right here, if it has like a red number on it, it just means that you have a message back from me waiting to be read. So that's where I will respond to any messages that you have from that. Just like the old SAT, questions are mixed between a handful of the fill-in questions and multiple choice questions that are options of 4, A, B, C, or D. Like I said, definitely look over the Blue Book app. And that's what the right-hand links are. These are the links that are the stuff from College Board. Okay, so they link directly to the College Board material. So here's the PDFs of their practice tests that they've put forth. These are the practice tests that you can take in the app, okay, or on the College Board site. Here's a link to the Blue Book app. Again, I've gone through it. I've looked at it. It has the things that I was expecting that it would have, which is oops, right here. It doesn't look quite like this. It actually has the graph above and the stuff that you can type in below. Okay, but there's a little calculator button that shows up on your Blue Book app when you're taking the SAT. So they include a Desmos calculator for you to use. And so a lot of what I'm going to be talking to you about is how to use the features of Desmos to answer questions, or at least to verify or check questions. So do practice using that. I've embedded it here, and if you click this link right here, it'll open it in its own tab, and you can move it around. But and then I have some separate notes that, as I do them with my classes, I'll post them here as well, that just show how to use Desmos to do certain things. Here's the thing is, the Desmos is not the only calculator, though. You can bring your own calculator. And since like we put a requirement or an expectation that you guys are using TI-89s and that everyone has one, you can take your TI-89 as well. Strongly encourage you to do that. In fact, as we go through this, what you will see is I would use the TI-89 specifically for like the factoring problems and working with expressions, like in power or properties of exponents. And then I would use Desmos for most of the other stuff. Although you can't just use TI-89 for everything. The only reason I'm making sure you know the Desmos stuff is I can't imagine a situation why they wouldn't like cut all calculator use, all outside external calculator use, and just allow Desmos at some point in time. And so that's part of why I do encourage you I'm going to show you how to use Desmos anytime that you can, anytime it's an easier process. Okay, so that's just sort of the general setup of how this class is going to go. So what we will do is we'll meet at 7 every morning except tomorrow, just because of the late start, the weird schedule, and we have department meetings at that time. Tomorrow will be after school, if you can make it. I will be posting video captures of everything that I do in class. The video captures will be located right after this. So right underneath where it says Monday here, I'll put a little link that just says video, and in parentheses I'll say how long the video is. So it'll be approximately 40 minutes. And you can watch that on your own if you miss a class and want to go back. So if you can't make it because of a practice tomorrow, there'll be a video link right there that you can watch on your own time. Okay. The last thing too is that like from here until you graduate, you guys can ask me questions about SAT anytime. Okay. Math, I won't be much help with the verbal stuff, but you're welcome to come in here. This is the room where I am, or in this office. You can send me an email. You have access to this Canvas site, again, until you graduate, so you can do practice problems. You can send me messages, and I'll communicate with you. Even if you have material from outside, of like something other than what I've done, you have a question about a problem, just bring it to me, and we can go over it, and I'm happy to answer it the best that I can. Okay. All right, any questions on just like kind of the logistics before we get going through the strategies? All right, so if you do have a TI-89, go ahead and take that out, because I am going to go through both by hand, by Desmos, and by TI-89 to show you how to do things, and you can pick and choose whatever's the most comfortable for you. And when I do that, I'll pull up this. I have a little virtual calculator, and you can watch either directly in front of your screens or up on the wall as I go through. All right, so really quickly, so I'm going to go through the odd questions in this course. Okay, and so if you're waiting for me to move to the next thing, you are welcome to kind of go in and answer any even questions. The very back pages, the last page front and back, have the answers to all of the solutions. And the questions aren't numbered, but I hope it's intuitive that the first, if your answer is the first option, it's A, B, C, and D from what you see on the answer sheet or the answer key on the back here. All right. So I'm also going to go through this in the order that they appear. So Algebra 1 content appears the most often, then Algebra 2, or this advanced math topics, and then problem solving and data analysis, and then finally geometry and trig. And so that's the order that the content will appear, and we're going to get through as much as we can. Again, this is the first class that I've done with this new format, so I don't have it timed down like I do, or like I have with my other classes. Okay? So we're going to just move forward from here. All right, so let's start with the most common topics from Algebra 1 that you're going to see are going to be linear equations that have a single variable. Okay? And so what I want you to do is I'm going to have you try the question on your own quickly, and then I'm going to show you how I would solve it. And I will generally show you the most efficient way that I think can solve it first, and then I'll go through and use the other devices that the calculators that you can use to show it. What you're also going to see is up on the top of each of these slides, I have relevant notes as well. I won't always read through these, although I will tend to expand on them if it's something that you really do need to think about. Okay, but for this one here, I'll talk about it after I go through. But again, I'll give you about 30 seconds to a minute to answer each question, and then we'll move on. And once again, as I said, we'll do the odd questions in this class. If you want to see videos for the even questions, I will have video captures of solutions to all of these questions up at some point. Okay? And so you'll be able to see them on that Canvas page. All right, so I'm going to go ahead and talk through the way that I would solve this is, and what the note here on the slide says. If you're being asked to solve something, and it doesn't just ask you for the variable. So it's not asking you to solve for x here, right? It's not asking you to solve for x here. It's asking you to solve specific expressions. Almost every time they ask you to do that, what you can do is you can manipulate the given equation very directly, and you can isolate that whole expression on one side of your equation. So here, if I look at this, I have 5 times x plus 4, and on the right side I have 4 times x plus 4. Well, the easiest way to solve this by hand is if I just subtracted this 4 times x plus 4 from both sides of my equation, what I wind up with is 1 times x plus 4. On the left side and on the right side, I'm just left with 30. Notice x plus 4 is what I'm being asked to solve. It'll lead you directly to the solution And so 30 is my answer to this problem. Okay. Now, if you're doing this with Desmos, and here again, this embedded calculator is going to be a huge advantage if you are familiar with it and comfortable using it, because if you just type this whole equation out, and when I talk through these, I'll try to give you any kind of like hints about it. But if you just type the equations out, if they happen to use a variable other than x, replace that with an x. And then you can pinch to zoom in and out and scroll over. Where you see your line crossing the x-axis is your solution. Okay, so 26 is what x is equal to. Now, remember here, the question wasn't asking us to find what x is, even though we see 26 as a distractor here. Okay, 26 is x. If we then take that 26 plus 4, that's the answer that we're looking for, which is 30. Okay, so you can use Desmos to verify this. And you can also use the solve feature in your TI-89. So if you have your TI-89 and you hit this F2 algebra tab here, you can select solve. And then once again, if you type the equation directly, the x's are along this line here above the equal sign. And again, the equal sign here on the left side, 4 times x plus 4 plus 30. Now the format for solving is once you type your solve command in parentheses, write the whole equation, and then comma the variable that you want to solve for, tells the calculator that's what you're looking for. This will confirm 26 is x, and then so when you solve this, x plus 4, 26 plus 4 is how you will get your other answer. Okay. All right, so that's using any of those, but again, by hand is a pretty efficient way to approach that. Okay, if we move to the next slide, I want you to see if you can answer this next question here. And if you're unsure how to do it, you can look at the notes on this slide. I'll talk about these in just a moment. But see if you can answer that first on your own. All right, when you have an equation with a single variable, now this also has another variable a that represents a constant, okay, but this is still really just an equation with a single variable x. You can have a single solution. You can have no solution. In no solution, what happens is that the variables cancel from each side of this equation, but you're left with constants that are different values. So here you might be left with something that says 3 is equal to 5. Since that's an inconsistent statement, there would be no solution. Okay, so if all of your variables or x's cancel, you're left with a statement that's not true, then it's a no solution. And if you look to combine those and both sides of the equation are identical, meaning all of the x's will cancel out and you're left with either 3 equals 3 or 0, if it reduce it all the way down to 0 equals 0. If it's a true statement and it's always true, the variables cancel out, then you have infinitely many solutions. Okay, so this one is asking you to find where would these cancel out, okay, meaning where would the right side of the equation look identical to the left side. So solving this one by hand is also probably the easiest way to approach it, because if you look at this left side of the equation, there's a common factor of 3. Take out that 3, leaving x plus 5 equals a times x plus 5. And right now you can see, if this has infinite solutions, then these are exactly the same, which means a would have to equal 3. Okay, so once again, solving by hand, relatively straightforward application. If you were solving this on Desmos, which you can do, and I'm just going to show you what happens when you have that extra variable. So notice here that nothing happens. Okay? It has this little warning sign. Okay? It doesn't understand that what a is supposed to be. So what you would have to do is you have to give a some number for it to use. Okay? And so in a problem like this, what you would likely do, or if you let a equal 1. So I simply typed in a equals 1. It creates this slider that you can scroll through. And as you scroll through this, notice that graph kind of flashes. It disappears for a second. Right where it disappears is where my solution's going to be. So if you want to solve this visually, you can just move that slider until it disappears, and that's going to be your answer 3. Okay. TID9, it's not going to give you any other advantage to solving this other than what these two can show you. All right, if you do have any questions, so as I'm going through this, this is mostly let you try it first, and then I'll show you how I would do it. But if you do have any questions, please stop me and ask me. I'm happy to answer your questions as we're going through. All right, let's look at question 5, see what you can solve from that. This one's a little more work. It does involve, or it requires you to remember how to work with linear equations. So this is the second type of problem that you would see is a linear equation that is modeled. Okay, so it's still a single variable, but it's a model now. Right, and so this is based on this linear form, right? So y equals mx plus b, where m is the slope, b is your y-intercept, okay, and the slope represents the change of whatever the unit change is happening, and then the y-intercept is the initial amount, or the constant value, or whatever's in the case of something being charged, it's an initial fee or the set fee that doesn't change. So when you're looking to solve a problem like this, you scan through, you see that this bin contained 35,000 bushels of corn after 8 hours, so that's the time that changed. It has 27,080 bushels. So what you can see right here is, in order to answer this question, we're going to need to create a linear equation and then test that linear equation when the value is 17,180 and see how much time expired. And so to do that, what we need to do is see that this is the initial amount of corn, the ending amount of corn. So when you take a slope is the change of y's over the change of corresponding x's. So let's take a look at how the outputs changed. So we started with 35,000 and we ended with 27,080. And that change happens over the time of 0 minus after the 27,000 and change happened after 8 hours, so minus 8. So this is going to give us the rate of this change. So if we just type this into the calculator, here again, I'm going to use Desmos for the majority of things unless it does not calculate it as. So here's my first calculation, then 0 minus 8. And so it gives me my rate of change. The m value is negative 990. So there's my slope. Okay, I already know that my initial, here's my b value. So this is now my m value, my slope. And so I have enough to create my equation for this problem. So y equals a rate of change, negative 990x plus my b value of 35,000. And what I can do is I can evaluate this function and solve. When y is this number, what is x? And so using Desmos, once again, it will solve equations for you, or you can use the solve feature of your calculator. But if you type in 17,180 is equal to negative 990x plus 35,000, you get your answer to be 18 for this solution. Okay. The TID9 would be the same thing. You can type that same equation in, but use the solve feature. I'm not going to repeat that unless we're doing something brand new that the Desmos calculator does not do. I'll generally lean on it. Any questions about finding the equation? All right. So go ahead and try the next odd question here, number 7, please. So notice the little notes here. Again, sometimes solving linear equations. If you're being asked to just solve for the variable, like you are right here and here, then you just type it in There's no reason to do it by hand unless it's something that you can do mentally. Now, if it asks you for that expression, then doing it by hand and just directly combining the sides of the equation are generally going to lead you right to that. But here, taking 1/7 x plus 6 minus 1/6 x plus 6, that's going to have me being working with fractions, which is, I can do it, but it's a more complex process, or you can multiply both sides of this equation by the LCD. Again, a more complicated process than what you have to do, which is, if you're solving for x, just solve the equation. Type in exactly what you have. Make sure you're using x's, though. Again, you can see in the problem below that you would have to manually exchange the p for the x. And so now, as I enter this, notice I don't see my answer showing up, right? If it was -6 or -11, I would have seen it by now. So I continue to zoom out. You don't need to be able to see specifically what the answer is, because the Desmos graphs will show you x-intercepts, y-intercepts, and any critical points. So like on a parabola, it'll show you a vertex. Okay? And it will show you any intersection of two graphs. So here we see that our x value is 204, and that's the answer we're looking for. Okay? So truly, as you're kind of we're obviously doing the easier stuff here to start with, but you hopefully are seeing this pattern of use the calculator. Practice it, do the app, see what because again, the calculator is going to be oriented a little bit differently. Okay? And just make sure you get familiar with your calculator. Get familiar with what is on these keyboard pads. So when you open up this keyboard, if you're using your calculator, or if you're not using the keyboard, attached keyboard, make sure you can find everything, pretty much here, the inequality symbols, pi, the square root button, absolute value button. And if you click on the letters here, you can choose any other letter. And also this symbol right here, which we'll probably get to today, this similar to symbol is going to be used as well. So make sure you can find all of that stuff, not just on what we're doing following me, but go in on the app, see what it looks like, because you do have to pull the calculator down. It's not automatically up. There's a little button on the top that you can press, and it'll open up the calculator for you. All right, so continuing with this algebra content, this is now switching gears a little bit to linear equations that have two variables, so x's and y's. Often will be the case, but try this first question right here. And again, you can read through the little notes. I'll talk through them before I start walking you through. So often if you see a question in this form, the coefficients of your two different variables are generally representing the rate per unit of that variable. So when I look at this problem right here, again, it's not a bad idea to scan answer choices to see what it is that they're asking you to find. So basically, you're looking to interpret what different parts of this equation represent. Okay, so if you are looking, the coefficient of A represents the per unit kind of cost of all x's. The B's are the per unit cost or charge or whatever of all the y units, and then C is the total. Okay, and so when you're looking for this, what does y represent? Well, y is attached to this 32. So find where does 32 exist in this problem. Okay, and so what you see is that the residential areas have an area of 32 hectares, some measurement name. And so that means that for every y, the y values times 32, where that's that rate of whatever exists. So what is it that you're counting? You're counting the total number of trees. So what that means is if there's 32 hectares and you're multiplying that by y has to be the average number of trees per hectare in that residential area. So if you are looking at this, it's not the total number of trees in the residential area, because that would be expressed by the whole quantity 32y. The total number of trees in the park would be, since the park is 3, it would be the 3x would represent that. The average number of trees in the park is going to be your X value, and the average number of trees in the residential area, that is your Y. That's what's being multiplied by 32. So this is just a matter of, again, being familiar with what the form looks like and being able to solve that story problem or that word problem. All right, let's take a look at taking these equations with the two variables and solving the equation. So see if you can answer this question 11 here. So with the amount of time that the SAT gives you, the hope is, or again, if I'm expecting that you're going to have time to go back and check answers. If you have time, if you finish everything before the time expires, go back, check your work, and use a method different than what you used to solve it. And so if you are solving like this one right here, to me, I would solve this one probably by using the calculator. Okay? But you could also solve it relatively quickly by like solving it by hand. So if you have time and come back, and if you're not quite sure if you got one right or if you did it correctly, you can double check the harder questions by using a different method. Okay, so the first method, when I look at this, again, what I'm seeing is they want me to find an expression of b over a, where b, you can see right here, is the y-intercept, a is the x-intercept. It's the x value when y is 0, b is the y value when x is 0. So that's what the intercepts mean on your graph. The nice thing is that Desmos is the graphing calculator, and it displays your x and y intercepts. And so if I just type this equation directly in, exactly as they gave it to me, what I can see now, this one I do have to zoom in, but I can see that I have, notice it's negative 18.5. That's my b value. That's my y-intercept. And when I click on my x-intercept, I get negative 4.625. Now, sometimes these aren't going to be, like, sometimes you'll see the decimal form that's rounded. Okay? And so it's not always like the greatest thing to find. Okay? But you can still use that. If you need to find b over a, meaning negative 18.5 over negative 4.625, you can just go in and calculate that. So negative 18.5, and then divide by negative 4.625. Even if it's an approximation, you're probably going to see the only number that it could possibly be. Right, so the answer is 4 here. 4, when you look at these, we have, this didn't reduce, but 4, 1/4, or sorry, 1/4, negative 4, negative 1/4. And so this is what we would be looking at. So that's how I would do it. To me, that's the easiest way. If you are going to do this by hand, though, it's also not bad to do this by hand, because if we want to find this x-intercept, we just let y be 0. Well, if y is 0, then 2 times 0 is 0, so that whole thing cancels out, and I get 8x is equal to negative 37. So I can see right here that my x-coordinate is going to be negative 37 over 8. And so that's the a value. And if I want to find my b value, what I would do is I'd go back here and I would solve, let x be 0. So if x is 0, that first term is canceled, and I get 2y is equal to negative 37. So my y value here, this b value, is going to be negative 37 over 2. And so here, if this is a and this is b, and I want to solve for b over a, I take negative 37 over 2, divide by a, negative 37 over 8. And when you divide by a fraction, you multiply by its reciprocal. So you can still do this, flip it, 8 over negative 37. The negative 37s cancel. I get 8 over 2. That's the form of this answer. And so you can do it by hand, but the more familiar you are with using your different calculators, the better. It is also possible to use the TID9 for this. If you are comfortable with the TID9, do it. You can plot this as well, but the Desmos makes it super easy. All right. Let's look at this next question, and we'll finish here with this question right here, 13, for today. And so see if you can answer that. Here, again, we're still dealing with linear equations with two variables. But this is, again, based on the slope-intercept form of an equation, y equals mx plus b. All right. So if you know that y equals mx plus b has a y-intercept of 0b, so what you know is that this is your b value. 4 is your y-intercept. So right away, what you can do is you know it has to be one of these last two options. Now, one of the features in the app that you will use to take your test, the Blue Book app, is there's a way to kind of turn in or open up this opportunity to check off boxes if you know it's not the correct answer. And so that will kind of eliminate the answer choices from the ones that you select. So if you're working by process of elimination, which is not a bad strategy on the SAT, open that box and you can, like right here, you would X those two out based just on that one point. And then what you could do is use the other point and test to see which of these expressions or which of these equations would work for that. So if y is -7 and x is 1, or y is -7 and x is 1, which of these is going to be a true statement? Well, here the bottom one is the correct one. The top one is not a true statement. Now, before I exit this, so this is how I would solve it. This, to me, is the easiest way to solve it. But I do want to introduce, this is a feature of Desmos that, again, unless you're familiar with it, you're not going to know. But Desmos has a regression function to it, meaning that what you can do is you can plot points and then come up with an equation of a line that passes through those points. And so to introduce that with this right here, this little plus symbol, this add item symbol, if you click on the add item and then choose table, what you can do is you can enter coordinates for your given points. So if I enter 0, 4, and then 1, -7. Now, for a linear function, you always need one more point than the degree or the power of your expression. So a linear function has a degree of 1, so we need 2 points. So we have our 2 points. What we can then do is go down in the next line and we can call on this linear regression. And the way that you call on it, and this is where you might use the keyboard on here, or if you have your keyboard yourself, if you just type y1, and again, it's very specific how you enter this. You need to subscript your x's and y's, and the reason for that is that's what the table uses, right? The table is using x1 and y1, so type in y1. Now, as you do, you don't have to physically try to subscript it. If you just hit y and then 1, it'll subscript that for you automatically. And then instead of using equal to, you're going to use that little tilde button, that little similar to. So if you go into the keyboard and find this button right here, it's also at the top left of your physical keyboard. That's going to get, that one designates that you're doing a regression. So this works for quadratic functions, exponential functions. It does quadratic functions in all 3 forms, like intercept form, vertex form, and the general form. But here we're looking at the slope-intercept form, so m x1 plus b. And notice it gives you what your slope and your y-intercept are. It draws the line in for you. Okay, and so this would show you that you're looking for a slope of -11, a y-intercept of 4, and so you can confirm that that is, in fact, the right answer.